Hey guys, welcome back to another episode of the Real Hacker Hours podcast. This is basically where I just do the normal work I would on side projects. I just hit the record button before I do the work. None of this is rehearsed, so you're probably going to see me make a lot of smooth brain mistakes, but without further ado, let's go. Today we're going to be continuing on. Right now I'm still working on the final pieces really of the Apache module fuzzer. In terms of that, what I mean is the framework of it that will enable me to quickly write fuzzers for individual modules. Right here, this is the module class, which when I write a let's say a fuzzer for the modder module, I'll create a modder module class and just inherit this from here. That way, a lot of the functionality that I'll need is already written there for me. This right here, this is the function that's primarily responsible for corrupting the data so I could fuzz and potentially probe for bugs. My idea behind how I want to do this is it will, let's say you're dealing with a module that the majority of the or all of the functionality is based entirely around the request line. What you'll do is you'll have a list with all of the different components of the request line, and it gets passed to the fuzz data, which then it can potentially fuzz individual pieces of that together. For that, currently I have 1, 2, 3, 4, 5, 6, 7 different fuzzing or data corruption methods available. First, we can just leave it out or insert multiple of this part. That could potentially help if it's let's say, parsing for a particular character or a particular thing, and then that influences memory operations later on. I've seen bugs where that is a thing. Of course, we can insert large data. I have two different data insertions. One is for ASCII strings, and the other is just any real bytes available. The reason why I have two different ones, ASCII strings, is because certain things will only work nice if you only have ASCII text, and data have that there because I wanted to be able to realistically insert any bytes there. Insert delimiters, again, that's for to check for parsing errors. Insert format strings, that's for format string bugs. And bit flipping, since this is primarily a text-based protocol, this is more or less just kind of mutating the data that is there, hopefully increase the entropy as to what the data that we can actually send it to fuzz. So one thing I'm gonna want to do right now that I'm just thinking of, this right here, leaving it out, I'm cool with how this is. It just zeroed out the part. For multiplying the part, I have some helper fuzzing functions: generate int, generate ASCII string, generate string, and insert string. This just inserts one string into another. These two are the two functions that generate strings for both ASCII only, which we define as this range, and then generate string, which is just generate any bytes. For generate int, I designed this function in such a way that there is no limit as to the size of integer that will get. Basically, what I'm doing is that there's just a while loop that will just run a random amount of times. Each time the upper limit gets squared by itself. Oh, I just made a smooth brain mistake. That should be limit. So there really is no hard-coded limit as to what this will become. Granted, most of the time it won't be 1 million or something like that, or 1 trillion. Or maybe it'll probably be more between the hundreds to hundreds of thousands range, somewhere along there. But we will, once in a blue moon, get these astronomically large numbers from it. And what I use to generate int for is for ASCII string and generate string, the size actually comes from here. So the sizes from these two functions, they don't have any hard-coded upper limit for how much data they can send. Now, if you send like, let's say like a gigabyte worth of data in a HTTP request, that will likely cause several problems with the connection. However, that's why I have function. That's why I will make functionality for detecting like, oh hey, it seems that our connection got cut off. Let's like restart or reinitialize it. So getting back to here, what I'm going to want to do is I want to, wow, what this is doing is it allows me to insert a random number of ASCII strings into here, which just gives it a tad bit more entropy in ways that I could potentially find bugs. And I'm going to do the same thing here. Cool. Now, for insert delimiters, what I'm going to need for this, I'm going to need a corruption choice is equal to 4. I should probably have like enums that specify like, oh hey, leave data out is 0, multiply part is 1, insert ASCII string is 2, insert data is 3, and so on and so forth. Since I'm inserting data, I kind of want to try out having it in this loop. Granted, in fuzzers I made previously, it didn't have that like while random int where just insert a dynamic amount of strings into it. But I kind of want to implement more entropy into this fuzzer because theoretically, the purpose of a fuzzer, hopefully on paper, is to exhaust an astronomically large amount of different ways you can throw data at it. So, to a certain degree, increasing that entropy should, in theory, lead to more bugs. Now, what am I doing? I need a def generate delimiters. Now, there's two ways I can make this function. What I'm first going to do is going to look at the ASCII chart. What could very well happen is all of the delimiters are probably between like a certain value, like certain values, like let's say all the delimiters between like 0x00 and like 0x20, 21, something like that. So I'm going to go ahead and pull up an ASCII chart. Let's see. Yeah, it looks like they're pretty much all between 0x00, just null, and 0x20 with del all the way there. Don't sure that's a delimiter. Yeah, I'm just for now going to have it be a range from there to there, and I'm going to throw a del in there just for the fun of it. If random.randint 0, 20 next byte equals random.randint 0x00 0x20 else next byte equals, this is 0x7f. Cool. So what I'm going to do, I'm going to have a while random.randint01. So it will add a dynamic amount of delimiters. Delimiters equals delimiters dot, wait, plus equals, you can't do dot append with byte strings. Next byte, and then we return delimiters. I just realized I don't have return type, hence cool. Okay, so this will generate a. Actually, let's make this OX20. That way it's more representative. Actually, more representative of the actual chance of having it there. Cool. So here we have the function which will generate delimiters. Here we have it inserts. So let's go ahead and write this. Delimiters equals this. Part equals insert string. Part delimiters. Cool. So we have that. Next up we have insert format strings. Option trace equals 5. Going to be very similar instance here. Format string equals generate delimiters. Part equals insert string. Part format string. Now I just need to write the generate format strings function. For now, I'm going to leave it as that. Now, actually, hang on one second. Okay, I'm back. Cool. So we are at the generate format string function. Now, there's multiple different ways we could do this. This is because there's a lot of different format strings we could use. However, if there is a format string bug, realistically, there are certain format strings that aren't going to help us in terms of just pure fuzzing, like %x, primarily the format string bug, or format strings that are used to like leak information. And the reason why they won't help us for the case of fuzzing, you have to think, what does fuzzing primarily do? It finds bugs. How do you know if it finds a bug? Typically, the target will crash and no longer be operational. For that, a %x, unless if for some reason it's like dereferencing a memory address somewhere. Actually, no. Sorry. For that, the format strings that are most likely going to give us a crash is going to be %n, since that's actually trying to like dereference and write to an address, which likely there isn't anything there. So I probably want to go with that, since if there is a format string, if we can send in %n, chances are that's going to give us the best crash, and on the off chance that there just so happens to be a valid memory address at the right spot, what we can do is we can have it alternate between different offsets, and from a practical standpoint, that should 100% give us the crash. Cool. So how are we going to do this format string? Let's have, of course, a random chance. So there's going to be two different ways we can do this. Here we just generate %n without offset. Generate %n with offset. Cool. Without offset, how are we going to do this? We are going to, well, the format string is going to be equal to % plus, I forget what the Python escape character is for that. char equals random dot choice. Let's see. And actually, I'm going to have this up here because both are going to need it. Excuse me. So we have that there. This will just generate either like a percent undercase or uppercase n. Here is going to be extremely similar. We just have an offset, and for that we're just going to use generate int format string equals. Just realized I made a mistake here. This should be a byte string, not a string. Percent plus offset plus char. And I see several issues with this code. These should be both byte strings, and also this needs to I don't want to use generate int. Reason for that being is that could very likely generate. We need, in order to convert the int to bytes, we need to use the .2bytes function, or that's the easy way. There's probably like a million different ways you could do it. That .2bytes is how I want to do that. For that, we need to know the size that we want to. And also generate int, I designed this such a way that there is a good chance that's going to give us a large number. I'm just going to have this random.randint between 0 and oxff. Offset equals This is probably a very janky way to do this, probably a better way, but for now I'm going to do this. I don't want to do just .2bytes. Reason for that being, yeah, I want to do it this way. If I recall correctly, actually, I'm going to just double check myself. If I recall correctly, format strings want the offset in ASCII. Let's see. Modules. Where is it? Format strings, yes. Let's look at a sample exploit. And yeah, they want it in ASCII. If I just convert the int to just .2bytes, it'll, like, let's say I give it the value ox30, it'll give me like /x30, not ASCII 30. And doing it this way will give me what I want, UTF-8. And yeah, that should work. Cool. Okay, that part should be running. The very last thing is just bit flipping. So for this, LF corruption choice is equal to 6. I'm going to iterate through for what's for byte in part. New part equals if random.randint. What should the probability on this be? Let's do let's make it a coin flip, why not? How am I going to do this? I want to. So the purpose of this function is to flip some of the bits of it to hopefully on paper get some additional permutations or just warping the data in ways that I don't really expect to do it, but let's just have that functionality just in case. So we're gonna generate a XOR byte equals random dot rand int, and this is just gonna be a random byte, and this byte is we're gonna OR it against XOR byte, and then we're gonna append it to new part, and then we're going to just set part equal to that. So what do we do here? We're effectively just iterating through each byte of the part, and if randomly we select a byte here, we just generate a new byte and we XOR it against it. Now, why did I pick XOR? Because the thing is with like ANDing, if we are ANDing a value against another, or if we're ANDing a value against one of these bytes, the only thing we can realistically do is take away or turn bits from 1 to 0. If we're ORing, we can only turn bits from 0 to 1. XORing, at least on paper in my head, gives us the most controlled influence, the most amount of bits. And yeah, for now I am liking how the corruption here is looking, so I'm going to leave that. And also, just to give you an example of how this looks, here is the modder module that I have. Now for the module, I have functionality for generating a request line, generating a header, generating a body, although I need to add this. For the module, for modder, the only real functionality it has is with the request line. So I just specified some additional functionality for that. And I also called self.fuzzData on the various different components of that. But yeah, this is what I mean by like, oh, hey, we can just quickly in like 40 lines write a fuzzer for a module. Cool. So what's next? Next, there's two different pieces that I think need to be worked on. Those two pieces are the functionality for like, oh, hey, identifying if the connection, we can still send data through and still use it, and if it gets to a point where we can no longer use it, automatically reestablish the connection. That's one of the functionalities I need to add. Another one of the functionalities I need to add is just some sort of crash identification. So the fuzzer needs to be able to tell when it has actually crashed the target. How I plan on doing that is, since this fuzzer is running on the Apache, I plan on just monitoring the PID of all of the worker processes, and if any of them die, I flag it. Now, there are several different ways you could do crash identification. One such way you might be able to do it for certain other network targets is you could just check, oh hey, is the target still responsive? Because in a lot of network targets, what you'll see is you get one crash and the entire thing dies. Here with Apache, the issue with that is there is multiple different worker threads, and if one dies because you crash it, others can still respond to it just fine. So the best way I can think of is just through monitoring process ID. I'm going to go ahead and write the crash detection functionality first. Self. Okay, cool. I forgot if it's Boolean or bool in Python. Cool. I'm just going to quickly Google Python 3, see if PID is running. Call os.kill p. Yeah, I remember seeing this. Yeah, os.kill effectively just sends a process or not a process, a signal to a process. I forget what the what signal 0 is, but I think it's not one that actually does anything. Yeah, even multiple articles are saying just to use os.kill 0. So I'm just going to do that. Let's do for PID in self.pids try os.kill PID 0. Okay, I think my dinner is ready, so I'm gonna pause real quick. Okay, my dinner still has a few minutes left in the oven, so I'm gonna continue on with this. So we're gonna trying to do this. If it throws an exception, it probably means that PID doesn't exist, so I'm gonna have a function that's just report crash. So for this to work, I'll need PIDs. I'm gonna need to add that field to the fuzzer. Now, what I could do, first thing that comes to mind is I can, as the user or the coder, specify what PIDs I want to monitor. That could either be through like I just have like a list here like PIDs, or I just specify it, or I pass it in through command line arguments. On second thought, what would probably be a better method potentially is there's probably a way in Python that can just like look up what those PIDs are and just automatically enumerate them, which I might want to do later. But for now, I'm just gonna have it hard coded. Actually, self dot enumerate PIDs. Self dot PIDs equals that. I just realized it's just iterating through all of the PIDs. If it's an empty list, it won't actually do anything. So I can just leave that there for now. So that's crash detection. Actually, let me go ahead and just test it out real quick. PS. Wait a second. I need to import a few additional libraries. I should probably run this fuzzer because I'm kind of like breaking one of the cardinal rules of programming where you write a bunch of code without running it, which there's probably going to be a ton of bugs in here that I have to fix because of that. Okay, it's not running. Let's try that. Okay, Apache, bin. Cool, let's run this. Cool, so this should be running now. Enumerate PIDs. Yeah, right, make a function for that. I believe there's also a function that we need to write for gotta crash. Self return. Make this up. Add PID enumeration later. Cool, I believe there's also you need to write a function for report crash. Def report crash. And I'm just going to have this just print out a message and just exit out. Also need to import sys for that sys.exit. Okay. This is module.py, generate int. Oh, I put limit when I should have done upper limit. Yeah, this is what happens when you run your code, well, write a bunch of code without running it periodically. Okay. Set corruption. Appears that when I run it, it just gets stuck a lot. So how I'm going to deal with this. Let's first... Actually, I'll worry about that later. I need to add additional functionality now. So I added crash detection. What's the next thing I need to add? It was, resetting or monitoring the connection and resetting it if it goes or just hangs or something like that. So let's first... So this is the function have for establishing a connection for sending a packet. This is the main fuzzing loop. How I'm going to want to do this. I'm going to want to... Let's have a function that's like self.check connection. Def. Well, if you think about it, we don't really need a check connection. Errors can be monitored when we send and receive data. So I can just, and then if there's an error, we can then go ahead and then reinitialize the connection there. So here we are, connect. We can put this in like a try statement. Try accept self dot failed comms. What this function will effectively do is it will just we'll store a value in the Fuzzer class called like failed comms, and this is just the amount of times we try to communicate and it's failed. And this will first increment that. Plus equals 1. And then check if self.failed comms is greater than. This is going to be an enum I'm about to add max failed comms. If that's the case, then I will just self.establish connection. And then after that, I will reset failed comms. Cool. So one thing I'm probably also going to want to do is add a socket timeout. That is basically when it's like after like X amount of seconds of trying to send or receive data and it just isn't working, just throw an error. So how do I do that? Let's Google how to do that. Python set socket timeout. Socket dot. Okay, it looks like it just dot get. Oh no, dot set timeout. So we will add a self dot socket dot set timeout. Socket timeout. So there are two enums you need to establish: socket timeout and max failed comms. Let's add these two. Socket timeout. Let's put it at 1 second. And max failed comms. Let's put this at 10. Cool. Let's see, does this work? And it is hanging. It runs, but it hangs, which that's going to be a major problem. Looking at it, it looks like you might have gotten a bit overboard with the multiplying. The multiplying part of the data corruption, which I just covered, or just wrote. Cool. So, okay, what am I doing? Let's first work or get the fuzzer to a point where it can run continuously. And so let's first go back to here. Let's go to this part right here and change this to a way lower number. 1 through 10. Let's try this. '84. And where is this? Line 84 of this file. Right here. Oh, forgot to add self. Wait, self dot failed column. Okay, I had a naming complexion. Failed columns as both the name of a function and the integer I was using to keep track of how many failed communications there were. So looking here, continuously it looks like it's crashing on line 15. Let's print the size. How big is this getting? Okay, yeah, might. Yeah, I probably need to add an upper limit to this. So upper limit equals let's have an upper limit. 1 million for now. And if upper greater than so what I did here is I just added a condition that I cannot extend past this this value. And now one thing you might be asking is why not just do a random.rand at 0 to there? And the reason for this being is doing it this way, we actually I can think of a better way I want to restructure this, but by changing what the upper limit is dynamically, we'll get I feel like a more diverse set, because when you have the same upper limit, even though it's like a million or something, most of the numbers fall into like the same kind of general range. But what I'm wanting to do is upper limit equals upper limit times 10. It's probably this is an awful naming convention with having both of these named upper limit. Upper, let's make this case sensitive. Upper Rng limit. They're different names, that way they don't get as easily confused. Host. Let's see this go. Looks like it hang. Let's cut it off at 1, 2, 3. 100,000. 2, 3. Let's see how this goes. Okay, this is a much steadier stream I'm seeing. However, I'm seeing a lot of the data that is being fuzzed, so let's turn down the corruption rate. Right now we have it at 50. Let's change it to 10. Okay, yeah, this fuzzer is running continuously now. Cool. So we have some functionality in there for resetting failed columns. Other functionality I probably would want to implement is Rng Seed Seeding. Reason for that being is, let's say okay, the fuzzer goes ahead, finds a crash. Cool. We know that there's a bug in there. Now, in order to, one thing that we needed, or would be extremely helpful for figuring out what the bug was, is if we could have the fuzzer repeat the same behavior, since it can do a ton of different stuff. Simply just running the fuzzer again against it, depending on the situation, good chance it won't just redo the same behavior. So what we effectively do is every time we run, we generate a seed and use that as our seed for RNG. If you guys don't know, most computer, or a lot of computer random algorithms out there, or actually probably most of them, they rely upon a seed value, and that's how they generate all of the numbers or random numbers on top of that. So if you have the same seed, same sequence, so we just generate and save the same seeds that we use to do whatever logic. That way, if let's say we get a crash, we can just, oh hey, I want to replay the last like 200 seeds or whatever, and that will, this fuzzer will behave the same manner. Cool. But yeah, there's definitely a bit more functionality I could add to the framework, but for now the framework is working. So what I'm probably gonna do is I'm gonna cut it off here. And I'm gonna begin working on some of like the module specific fuzzers. Thanks for watching. See you later.